Hello everyone, welcome once again. In this lecture, that is lecture number 2, we'll be discussing the numericals based on our lecture 1, which was hybridization, geometry, shape, number of bond pair and number of lone pairs. To it, we would be adding two more things, that is isostructural and isoelectronic. Let us solve this first example. Most of the examples that we are going to discuss, or rather which I have included over here, are from the previous year's question paper. The shape of IFI, XEF4 and NiCN for 2 minus is asked. If we look into the question very properly, we are to write, or we are here supposed to mention the shape, not the geometry. So be very precise that we are supposed to give the answer based on the bond pair alone, because we know very well now that bond pair plus lone pair together will result into geometry, but when it comes to shape, it is the bond pair that plays the key role. Let us start with the first example, that is IF5. See friends, when you are asked IF5, you have to go through the shortcut that we have discussed in our previous class, where iodine has 7 lone pair of electrons, each fluorine has 7, and you have 5 such fluorine. So the total over here is 7 plus 35, which is 42. So now when we have 42 as our answer, we should be very clear that 42, so it falls in the range of 9 to 56. So you need to divide it by 8. So when we are dividing it by 8, it is 8 5 times 40. 2 is the one which is left, so 2 is our remainder. Now it falls in the range of 2 to 8, so you need to divide it by 8. So 2 ones are 2 and it is 0. So friends, you can see that 5 and 1 is our answer. So be very precise. 5 and 1, when 5 is your bond pair, 1 is your lone pair, so it is sp3d2 hybridization, because the total is 6, but the type of molecule is ab5l. Now remember, it is ab5l, it is sp3d2, and keeping these two things in mind, I did made you one thing very clear while I was teaching the theory in the earlier class, that you have 5 bond pair and 1 lone pair, so we generally coin it as square pyramidal. So friends, it is very clear that IF5 will be square pyramidal, and looking to the options, and the word respectively means in the order first IF5, so the first name corresponds to IF5, so I will move with option 1 and option C, I will not move with option B and option D. Now coming to the second molecule, it is XeF4. Now I will go little fast. XeF4. So xenon will be 8. Fluorine will be 7 into 4, 28. So it will be a total 36. When I divide this total 36 by 8, it is 8 4 times 32. I am left with 4. So it is 2 times 4, and the answer is 0. So it is 4 plus 2, 6. So 4 bond pair and 2 lone pairs, so it will be AB4 L2 type molecule, and when it is AB4 L2 type molecule, it is very clear that Xe F F F F, one lone pair on the top and one lone pair on the bottom, but we do not consider lone pair while going for the shape. So the shape is square planar, and friends, I have square planar in both the options. So I am quite sure that my first two answers are completely correct, whether it is square pyramidal or whether it is square planar. So everything that is now dependent is dependent on the third option, that is NiCN4 2 minus, and it will give me the results. Friends, we will keep it untouched because this comes under coordination compounds. We are left to do it, but as of now, we are solving the questions related to hybridization, related to structure, related to shape, related to molecule. We will keep the third part untouched because it comes up in another lecture, but we are clear that it is IF5 and it is XEF4. I'll go with square pyramid and I'll go with square planar. So this is how you can solve a question while moving ahead. Let us check the second one, tricylyl amine. Now this is one of the very lucrative question. Why I'll tell you. SiH3 thrice N is always compared with CH3 thrice N. Always a comparison is done between these two molecules. When we think of CH3 thrice N, it is something that is to be written like this. So the geometry is tetrahedral, but the shape would be pyramidal. But friends, remember over here, the lone pair of this nitrogen over here in this molecule go with the p pi p pi back bonding. But when it comes to silane, that is silicon, the silyl group, it has d pi p pi. The d of silicon and the p of nitrogen will come into existence, and therefore it will have a d pi p pi back bonding. And when this d pi p pi back bonding comes, it is no more pyramidal. It shifts to trigonal planar. So we will have a different type of molecule available with us. Friends, be very clear. It is no more a pyramidal geometry. So never go with pyramidal. Octahedral is not possible. Tetrahedral is not possible. So it's a plain triangular structure. So friends, be very clear. The structure that we are going to discuss over here is a plain trigonal structure. It is one of the most exception cases that we have when we go with the topic of hybridization, the topic of geometry, and the topic of shape in the case of inorganic chemistry. So be very clear. The reason is also mentioned to you over here regarding the d pi p pi, and what is this d pi p pi and what is this p pi p pi. Back bonding is a total different topic which takes another 10 to 15 minutes. But as of now, when we are solving the questions, we will just move ahead with the question number 3. I hope you are clear with question number 1 and question number 2. Friends, these questions are taken from different free websites where different papers of different universities regarding their PAT exams are available for free. Hybridization of Xe in XeF2. Again, a very simple question, but we won't stop only with the hybridization. We'll go for all other answers. Let us check. When it is XeF2, it is xenon with 8 electrons, fluorine with 7 electrons, so it is 8 plus 2 fluorine, 7 each, so it will be 8 plus 14, you will end up with 22. When you end up with 22, it is in the range of 9 to 56, so you need to divide it by 8, and therefore I'll always write 22 divided by 8, so it is 8 2 times 16. When it is 8 2 times 16, you are left with 6. Again, I need to divide it by 2. So 2, 3 times 6 and it ends up with 0. When it ends like this with 0, it is 2 plus 3 combination. So the combination 2 is a bond pair. The combination 3 is a lone pair. So the summation of these two is 5, and 5 always corresponds to sp3 dehybridization. So our answer is sp3d. Friends, assuming that we are not asked hybridization, and if they would have asked us type of molecule, then 2 bond pair, 3 lone pair, it is AB2L3. So be very precise what is asked, what are you answering. It has 2 bond pair, 3 lone pair, so its geometry or structure has to be trigonal by pyramidal. But friends, if I am talking about the shape will always involve the bond pair, and so the shape over here would be linear, and the bond angle over here would be 180. So these are some of the important things when it comes to hybridization. I hope you are getting these questions. These are the questions which are frequently asked in different exams. as we have taken XeF2 over here. Remember one important example that I had discussed with you, that was XeO2F2, it was seesaw. Another important example which we did over here in this same category was XeOF. Friends, remember very well these examples because this example belonged to the same category of hybridization, that is sp3d. The only thing that changed over here was its shape, because if you remember, in sp3d category we did a huge discussion which involved AB5, AB4L, AB3L2 and AB2L3. So that is important. Let us move ahead with another set of questions. The structure of AuCl4 minus anion. For this we needed the electronic configuration of Au, gold. So if you see the normal electronic configuration of Au, it is 5d10 6s1. Now let us calculate the oxidation state of Au over here. If you check it, it is Au plus 4 into minus 1 is equal to minus 1. Therefore, Au is equal to minus 1 plus 4. You will end up with plus 3. It means you are taking 3 less electrons. When 3 electrons are less, 1 electron will be eliminated from here, second from here, and third from here. So it looks something as if it is 5d8 and 6s0. Now, as 4Cl minus approach, nevertheless, it's a weak field ligand, but its hybridization is DsP2, an exceptional case. So when the hybridization is DsP2, there is a resplitting, and due to this resplitting, pairing takes place. It is not only T2GEG, but this T2GEG is again getting splitted, and therefore pairing takes place. And so you have an empty orbital over here, second, third, and fourth. And when the 4 ligand approaches, it is DsP2 hybridization. So friends, be very clear. It is an exceptional case. When you have such kind of exceptional cases, and when you have DsP2 type of hybridization, octahedral, square, pyramidal is not possible. Tetrahedral mostly corresponds to sp3, so that also won't be possible. So it is only possible if you have square planar available with you. So this is the way that sometimes the core theory does not work. You should know few exceptional cases, and these kind of exceptional cases can only fetch you a very good score when it comes to competitive exams. ICl4 minus, the hybridization of iodine. I have already mentioned it in the first lecture that these are known as interhalogen compounds, where the cation is of larger size halogen and the anion is of the smaller size halogen. Let us calculate. Iodine is 7, 4 into 7, each chlorine is 7, 4 chlorine, and minus 1 means 1 electron extra. 1 is going to be added extra. So it is 7 plus 28 plus 1. So it is 28 plus 8. You end up with 36. Now, be very clear. You are ending up with 36. 8, 4 times 32. You, apart from having 8, 4 times 32, you are left with 4. When you are left with 4, you are going to divide it by 2. So 2 times 2, so 4, and therefore it will be 0. So you have 4 bond pair and 2 lone pair. Now comes the question. There are 2 lone pairs, but at the same time you can only see one negative charge over here. So in this particular question, if you are having some ambiguity, you can approach me separately. We will try to solve it very precisely. But as it is 4 and 2, we have always made a summation of 2, and it is 6. And we very well know that 2, 3, 4, 5, 6, 7, SP, SP2, SP3, SP3D, and sp3d2, and therefore the hybridization over here has to be sp3d2 type of a hybridization. So friends, this is where hybridization comes into existence. Nevertheless, if you have any query in this particular question, you can write me. We will bring a solution and an explanation to it. Hybridization of xenon atom in XeF4. Again, it is XeF4, so xenon is 8, 7 for each fluorine, so it is 28. So it is 8 plus 28, we will end up with 36. Whenever we end up with 36, we always divide it by 8. So 8, 4 times 32, 4, 2, 2 times 4. So it's 4 and 2. So 4 plus 2, the total is 6. So when the total is 6, again, just now we did it, that it is sp3d2 hybridization. So this is our correct answer. Imagine if it was type of molecule, we would have ended up with Ab4L2, 2 bond pair and 4 lone pair. It's geometry. Let us write these two things. It's a humble request to bear little bit with my handwriting. They are not so good with this new technology, but I am trying to manage the maximum I can. It's octahedral geometry and square planar shape. So friends, this is how it works. It's a octahedral geometry and it's a square planar shape. So this is how we have solved this example and we are still moving ahead. The hybrid orbital is used by bromine atom in BRF3. Let us check. Bromine is 7. You have 3 fluorine and each fluorine is 7. So 7 plus 21, we will end up with 28. When we end up with 28, we will divide it by 8. So 8 3 times 24, 4, 2, 2 times 4, so it's 0. So it's 3 plus 2, the total is 5. So you have a total of 5. When the total is 5, the hybridization is sp3d because the total if is 2, it is sp. The total if 3, it is sp2. The total if 4, it is sp3. The total if 5 is sp3d. And therefore the hybridization corresponding over here is sp3d hybridization. Over and above. Apart from this, if it would have been the type of molecule, it is 3 plus 2, so it is Ab3L2. The shape of this molecule is extraordinary. It is bent T. F, 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 two lone pair. As it is bent T, these two angles will be less than 90 degree. Remember this very well. These two angles will be less than 90 degree. It's a bent T shape. This will help you get a practice of different questions and theory related to them are already made clear in the first class. So let us move ahead. What is the hybridization of XeF4? It's a repetition, but the reason for keeping it again is you will get an idea that questions are also repeated and we should know that. So XeF4 will again correspond to sp3d2. We will not repeat it because if you look into very carefully, it was done over here and I am writing it again or showing it again to just have you an idea that the topics hybridization, type of molecule, bond pair, lone pair, they are quite important. Let us move ahead. Pair having the similar geometry Very simple and a shortcut to it. When someone asks you similar geometry, always tell them similar hybridization. In most of the cases, you will win because geometry depends on both bond pair and lone pair, and both bond pair and lone pair together forms hybridization. Let us check. Let us first solve the one that are not complex. XEF4, SF4, SIF4, these three examples. XEF4, just now we did. We are much clear. sp3d2. SIF4, be very precise, be very clear. SIF4, let us calculate. Silicon is 4, each fluorine is 7, so there are 4 such fluorines, so it will be 28, a total of 32, and 32 divided by 8, it will end with 4. So 8 4s are 32, so you will end up with sp3. So XeF4 it is sp3d2, SiF4 it is sp3. When it comes to SF4, when it comes to SF4, it is a little different. How I'll tell you, just be aware. Whenever we say SF4, it is 6 of sulfur, each fluorine 7, so 7 4 28 plus 6 34, and when you will end up 34, you will end up with 4 plus 1, that is sp3 dehybridization. So over here, as it is sp3, the geometry will be tetrahedral. As it is sp3d, the geometry will be trigonal bipyramidal ideally. Even the shapes are not equal, so you will never end up with this as a similar geometry. Now, XeF4 is sp3d2. Its geometry is octahedral, but its shape is square planar. So for XeF4, it is sp3d2, octahedral geometry and square planar shape. But for SF4, the hybridization is sp3d, the geometry is trigonal bipyramidal, and their shape is square pyramidal. So I do not find any similarity either in hybridization, either in geometry, or in the shape. So let us eliminate this also. So now you are left with two other examples. And when it comes to these two other examples, it again falls in the category of coordination compounds, that is complex forms. So as we have left one question untouched in the very starting, NiCN for 2 minus. Similarly, I'll keep this section untouched for this particular reason. Otherwise, we all know PTCl for 2 minus, FeCl for 2 minus can be calculated, but we will do it. But as of now, when we are focusing on these inorganic compounds, and you know, according to the schedule, you have a separate class on coordination compounds, we will not take much time on that. And let us move ahead with another solution. Now comes one more important topic, and that topic is isoelectronic. Isoelectronic indicates the same number of total electrons. So for N2, it is 7 plus 7, the total is 14. CO, it is 6 plus 8, the total is 14. So yes, this pair is isoelectronic, but we do not want, does not contain isoelectronic molecules. This contains NO plus. When it comes to NO plus, 7 of nitrogen, 8 of oxygen, that is 15, but this plus sign indicates one lesser, so it is 14. When it comes to N2, it is 7 plus 7, again it ends up with 14. So yes, definitely it is isoelectronic species. So the first and the second are the pair of isoelectronic species. Let us very carefully go with the third pair and we will get an idea. See, NO, nitrogen and oxygen. 7 from nitrogen, 8 from oxygen, the total is 15. N2 minus 7 from nitrogen, 7 from another nitrogen, 14. 1 negative means 1 extra. So it is 15. So friends, 15, 15. Yes, definitely it is isoelectronic. So as these three options are isoelectronic, the fourth is not going to be isoelectronic, and that will be our answer. Elimination method. But definitely we should solve it. We should not directly write. So over here nitrogen is 7 and oxygen is 8. So the total is 15. Over here carbon is 6 and oxygen is 8. So the total is 14. So the total number of electrons in the molecules are not same, and so our answer of not being similar goes to carbon monoxide and nitrogen dioxide. I hope this was very clear to you. Moving a step ahead. Among the following, the isoelectronic and the isostructural pair is. Isoelectronic and the isostructural pair is means it has to be same. CO2 and SO2. It is 6 electrons for carbon and 6 plus 6, 12 electrons for oxygen, so the total is 18. On the very contrary, over here you have 16 electrons for sulfur and 16 electrons for oxygen. Friends, I have a mistake committed over here, so I will just repeat it so that you do not get confused. Carbon has 6 electrons, one oxygen has 8, so it is 8 plus 8, 16, so the total will be 22. But over here in SO2, the sulfur is 16, each oxygen is 8, so 16, so the total is 32. So the total number of electrons in the molecules are not same. Sometimes few people say that do not take the total electrons, take the valence electrons. Let us check, that is not an issue. Carbon has 4 valence, oxygen has 6, so 6 to 12, 12 plus 4, 16. If I go according to the valence. Over here it is sulfur 6, oxygen 6 plus 6, 12, so the total is 18. Even then, it is not at all isoelectronic. And even if you go for the isostructure, it is not there because CO2 has a linear structure. Whereas this SO2, if I talk about the structure, it is not at all linear. It's a trigonal structure and its shape is a bent shape. So the first example won't work. Let us move ahead by the second step. SO3 and SeO3. SO3 and SeO3. Now, if I take this example, SO3, 16 electrons of sulfur and 8 threes are 24 electrons of oxygen, the total is 40. If I am not mistaking, the total is 40. The sulfur has 16 electrons, whereas each oxygen has 8, so 8 threes are 24. If I talk of selenium, SeO3, how would we reach selenium? Oxygen, sulfur, selenium, tellurium, polonium. So if this is 8, this is 16, this has to be 34. 34 plus 24 is 58. It does not work. For a while, let us take valence electrons. So for sulfur, the valence electron is 6. For each oxygen, the valence electron is 6, so 18, and the total will be 24. For SeO3, if sulfur has 6 valence electron, it is but obvious. Selenium has 6 and it is 18. So then definitely these two are going to be isoelectronic. But what about their structure? That is obtained only from its hybridization. And whether it is SO3 or whether it is SCO3, let us check. As the total is 24, it is 8 threes are 24. As the total is 24, 8 threes are 24. So 3. So as of now, I can say that for these two examples, it is isostructural. For telling it isoelectronic, I would ask you to go a step ahead. NO2 plus, NO2 plus, and TeO2. So it is 7 plus 8, 15. 2 plus it is 13. And over here, as it is TeO2, this will be tellurium. So still 18 more electrons of 52. So I do not find over here any isoelectronicity because the total number of electrons will have a huge difference. So this is isostructural but not isoelectronic. This is neither isoelectronic as of now nor isostructural. Coming to this fourth example, that is SiO4 to the power 4 minus. Silicon has 4 valence electrons. Each oxygen is 6, so 6 4s are 24, and 4 extra, 4 minus. So it is 32, and when you have 32 and you divide it by 8, you end up with 4. When you end up with 4, it is sp3. So it has tetrahedral structure. When it comes to PO4 3 minus, we have already discussed it in the first lecture. Phosphorus has, let me do it over here. PO4 3 minus. Phosphorus has 5, 4 oxygen 24, and 3 extra. Again 32. When I have 32, I'll divide it by 8. 8 4 times 32, as it is 4, it is sp3 and it is tetrahedral. So friends, over here, when it comes to PO4 3 minus and SiO4 3 minus, SiO4 4 minus, I am very much sure that both are tetrahedral, so both are isostructural. What about isoelectronic? Let us just bluntly make the total. Phosphorus is 15 electrons. Be very sharp. Oxygen is 8. 8 fours are 32. 3 minus means 3 extra. 15 plus 3, 18 plus 2, 20, 50. So there are 50 electrons from PO4 3 minus. Let us go with SiO4 4 minus. Silicon is 14. Oxygen is 8, 8 fours are 32, and you are going with 4 extra. 14 plus 4, 18, 20 and 3, 50. So yes, friends, it is the option number D, where you have both isostructural and isoelectronic. Isostructural, its geometry has to be same, जिसको हिंदी में भूमिति बोला जाता है. Isostructural and isoelectronic, total number of electrons in the molecule has to be same. So friends, we cracked it. It is SiO4 4 minus and PO4 3 minus. Again I am telling, at any instance, if you find any doubt, you can please approach me, because for me it is also a learning process. I do not consider this as a teaching process. I consider it as a learning process for me too. Let us solve this example. Similar shape. So its shape, it is bond pair only according to my theory. CO2 and H2O. CO2 is a linear shape, whereas H2O is a bent shape. So no, it does not work. So first option is gone. Friends, option number 4 I'll take first, because in exams there are few options which we know very well, pretty well, so we always tend to solve them first, and that has to be done because you are also fighting with the time in the exam. So if you want to fight against the time and win, time management is also there. So friends, over here, this is planar triangle, this is pyramidal. So this is planar triangle, this is pyramidal, so even this option is gone. You are getting it, right? Shapes, only bond pair. Now it is CCl4 and PtCl4. CCl4 and PtCl4 will not work because CCl4 is tetrahedral, whereas PtCl4 is not tetrahedral, it is square planar. It is exceptional case. If you would have learned your inorganic chemistry in your final year BSc, you have reaction mechanism of coordination compounds. In that you are replacing Cl with different anions, and there it is very clearly mentioned PtCl4 is square planar. So even this option does not work. But BF3 works with CH3 plus. Why I'll tell you. BF3 just now I taught you, and even I have taught you in the lecture 1 that it is trigonal planar. And now for CH3 plus, you do not have to remember anything else apart from SN1 mechanism of organic chemistry. In SN1 mechanism of organic chemistry, you know that when you have CH3 plus, the attack is possible from both the ways. And during that time, this methyl carbocation is planar. BF3 is also planar. Both are trigonal planar. So option B is correct, where the shape is planar trigonal. So I hope you are getting these type of questions. Friends, in any of the question, if you have any doubt, you have any ambiguity, I am there to solve. I am there to resolve the question. I am there to resolve your queries because I might also get something new to learn from you people. So be very precise. If you have any query, I am there to solve it. SnCl3 minus. We have to check out the shape. These are not geometry, these are shape because pyramidal is not a geometry, it's a shape. T is a shape. There is a hint that the question is given is a shape. Sometimes you have a query that the options given are geometry or shape. Geometries are fixed, linear, trigonal, planar, tetrahedral, pentagon bipyramidal, octahedral, and trigonal bipyramidal. But when you find pyramidal, when you find T, you itself get an idea that they are shape and they are not geometry. So SnCl3 minus. Tin has 4 valence electron because it is in the carbon family: carbon, silicon, germanium, tin, and lead. So it has 4 valence electrons. Apart from this, each chlorine has 7, 3, and 1 negative means 1 electron extra. So 7 threes are 21, plus 4 25, plus 1 26. So its total is 26. Let us do it again. Chlorine is 7, 7 threes are 21, 4 from 10, 25, and 1 26. When the total is 26, I need to divide it by 8. So 8 3 times 24, I am left with 2. 2 1 times 2, 0. So it is a 3 plus 1 chemistry. Nevertheless, it is sp3. Nevertheless, it is sp3 hybridization. Definitely, it's a tetrahedral geometry. Nevertheless, it's a tetrahedral geometry. But I have been asked the shape. So I'm drawing it. You just have a look on it. Sn, Cl, Cl, Cl. This is not there completely because I have a negative charge over here. I'm just showing the negative charge. I'm not showing the lone pair. I'm showing that negative charge as a part of lone pair. So over here, as we are going for the shape, I will not consider this. And if I do not consider this, this is a pyramidal. So my answer has to be pyramidal. So friends, be very clear. You will also get a doubt over here that sir, they have also given the geometry tetrahedral. What shall we do? Sometimes in such kind of questions, there might get a bonus score because of the presence of tetrahedral. But it's very clear that as there are options related to shape, I'll go with shape. It will be pyramidal. If someone goes with geometry, it has to be tetrahedral. Even if you have any ambiguity in this question, you can just approach me. This question is yet left to be solved completely. This is a long theory which I would recommend you to learn, and this is yet to be solved completely. So friends, these are few of the questions that we have done, and I welcome your suggestions. I welcome your feedback in the comment box. I welcome new questions in the form of doubts from these topics if you have in the comment box, or you can email me personally. I'll get back to it. So thank you friends for your patient listening. Hope the two lectures that have been prompted have helped you. We'll be meeting in the lecture 3 with something new to learn. Thank you.